So 2 points A and B have coordinates -1 and 1, and 3 and 4 respectively. Line BC is perpendicular to AB and intersects the x-axis at C. Find the equation of BC and the x-coordinate of C. So we have 2 points -1 and 1, and 3 and 4. So if we just visualize what's happening, we could have the point -1 and 1. And then we have the point 3 and 4. So 3 and 4 is going to be on the right and a little bit further up. So it's 3 and 4. And this is the line that's joining both of these points. So this is A and B. A and B. So to say the line BC is perpendicular to AB and intersects the x-axis at C. So BC is perpendicular to AB. So notice B is the point in which we have this perpendicular line, and C is where this line hits the x-axis. So we could have the x-axis coming in like this. So C is the point on the x-axis, and in the y-axis, this is where x is -1 and x is 3. So x is 0 might be somewhere like here. So here we have the y-axis, and here's the x-axis, and here's point C. So just make sure that makes sense. The line BC is perpendicular to AB, and C is the point where it hits the x-axis. So just before we even start this question, this point on the x-axis, this is where y is equal to 0. So this point here has some x value for its x-coordinate, but its y value is 0. Okay, so find the equation of BC. Okay, so remember to get the equation of a line, you have to firstly have its gradient. So we need the gradient of BC. And then we have to have a point x1 and y1, which lies on the line BC, which we have here as B. So we can use B as a point on this line to get the equation of this line. So the only thing we actually need here is the gradient of BC. And since we know BC is perpendicular to AB, if we can find the gradient of AB, we can then get the gradient of BC. So the gradient of AB, which is change in y over change in x. So we can take x1 and y1 as B, x2, y2 is A, but it could be the other way around. So y1 minus y2, we can say 4 minus 1 over x1 minus x2, which will be 3, minus 1. So this becomes 3 over 3 minus 1 is positive 4. So now if we know that the gradient of our one line, which in this case is AB, times the gradient of the perpendicular line, which is BC, we know that this has to always come to -1. So if AB has a gradient of 3 over 4, we're trying to find M2, which is the gradient of BC. If we divide both sides here by 3 over 4, we get that M2, which is the gradient of BC, is -4 over 3. So now we have the gradient of this line. So we have the gradient of BC is equal to -4 over 3. And we have a point on the line, which is B, 3 and 4. We can now sub these values into y minus y1 is equal to the gradient x minus x1. So y minus y1, so we can say y minus 4 is equal to the gradient, which is -4 over 3, times x minus x1, which is 3. And now we just get everything to one side. So -4 over 3 times x is -4 over 3x. -4 over 3 times -3 is positive 12 over 3, which is 4. And then to get rid of the -4 on the left-hand side, you have to add 4 to both sides. So plus 4. 12 over 3 is 4, plus 4 is plus 8. So this is the equation of BC. So this part of the question is done. But now we just need to get the coordinate of C, the x coordinate. So if we know that C is where y is 0, all we need to do is substitute solve for x to find the x value for which the y is 0. So we're going to make y 0 minus 4 over 3x plus 8. And now we get x by itself. We can subtract 8 from both sides. And then we can divide minus 8 by minus 4 over 3 to get our x is equal to 6. So this coordinate here is 6 and 0. And that's the end of the question.